All right, so let's take, for example, now we're looking at 48% of 500 students are so let's take a look and let's say, okay, let's suppose that we have like number 5 here, okay? And we talked a little bit about how we're going to choose what it is that we're going to do. But let's see, I've got number 5 says that 48% of 500 students randomly sampled from college A drive to school. And then 67% of 625 students sampled from college B drive to school. Estimate how much more of a proportion of students from college B drive to school compared to the proportion of students from college A. So what I'm going to do is I'm going to run a hypothesis test, and I'm actually going to estimate a difference, okay? Estimate a difference of the proportions. So we said, okay, it's a 2 sample proportions, and we're looking for the difference in the 2 samples, all right? So I need to take some information here. One is I've got a p hat for group 1, let's say, or from college A, all right? And from college A, I've got p hat is going to equal 0.48, all right? So there's 0.48, and my n is equal to 500. And then from group B, right, okay, my p hat is going to equal 0.67, and my n is going to equal 625, okay? So what I'm going to look at now in order to draw this interval and to talk about the test is I'm going to ask myself, okay, whether or not is there a difference between the 2 proportions? So my H naught, my null hypothesis here, okay, is going to be that P1 equals P2. All right, or the proportion A is equal to proportion B, all right? Then my HA, all right, I'm going to look how much of a proportion of students from college B, right, how much more of a proportion of students from college B drive to school compared to the proportion from students of college A. So that's going to be P1, right, is going to be less than P2 because P2 is my group B and they're the bigger group, okay? So that's my null and my alternative. Yes, notice B is the bigger group, so that's why we have the greater than sign pointed towards our group B. Yes? That's just reading. Reading and knowing what is the proportion test that I'm going to be running. Now, here's the thing that's just a little bit tricky here. When we run with StatCrunch, or we use StatCrunch, what we want to notice is that in StatCrunch, we're not actually asked for a p hat, right? So we got p hat 1, p hat 2. What we need to find is we actually need to find the number of successes. So p hat 1 is going to equal x over, right, n. And so that's going to be 0.48 is going to equal x over 500. So to find x, we're going to take 0.48 times 500. And that's going to give me my number of successes, which is actually really important for me to be able to actually use my technology in order to do this, okay? So 0.48 times 500 times 500. Okay, and that's 240. So what I'm being told here is that x, my x is equal to 240. So that's going to be my number of successes. Then I have p hat 2, which is my second grouping, and that's going to be x over n. Okay, and that means that's going to be 0.67. Okay, 0.67 is equal to, and again, x, the number of successes, now over 625. And we're going to actually, this is going to end up giving us an estimate. So x here, my x1, my x2 is going to equal 67 times 625 is 418.75. Just call it 419. Okay? So we'll round up to 419. x2 is 419. Okay, so we've got 419 out of 625, and we've got 240 out of 500. Now, what I want to be really careful about here is before I run this test, I want to ask myself, what am I trying to do? I'm trying to reject, right, this thing here. That's what I want to reject. It's a hypothesis. Will I reject it or will I not reject it? So the question is whether or not do I believe that the proportions are actually equal to each other? And so when I find out what my p-value is and I compare it to alpha, right, I want to see whether or not I actually am going to reject that statement. Now, we are not given an alpha here, so let's just assume that alpha is equal to 0.05. Okay? And now I go into StatCrunch. I'm going to go in here to stat. I'm going to do my proportion stats. And this one here is for 2 samples, and I've got a summary. I've got summary information here. So for the first one, remember we had 240 out of 500. So 240 was the number of successes out of 500. And that's why I actually went in and I did what I did, right? 240 out of 500. Okay. And then for my sample 2, I had 419 out of 625. So I'm going to put those in. Now, my null hypothesis is this one, P1 minus P2 equals 0, right? That's the two of them are equal. And then if you remember, our alternative was P1 minus P2 is now less than 0, right? We had the less than sign that we used. Okay, because we were hypothesizing that P2 was actually going to be bigger than P1. All right? When we end up talking about the interval, this is going to end up being really important because the interval is going to estimate this thing, P1 minus P2. Okay, so we'll get to there in just a moment. So now I go in, and now I've got a p-value of less than 0.0001. Okay? So I've got all my data in here, all my information. So now I've got P, right, is less than 0.0001. So consequently, that is P is less than alpha. So I'm going to reject the null. Now I have what my conclusion is. Now I actually need to write out what my conclusion actually is. Okay? So let's go in and do that. What did I just do? I rejected this statement right there. That's the null hypothesis. That's the thing I rejected. All right? Very, very important. So there is sufficient evidence, right? Because what I'm trying to do is reject. So there is sufficient evidence to reject the claim that the proportion of drivers from college A, this is so huge, is the same as the proportion from college B. That's what I'm rejecting. I'm saying that's not true. When I rejected the null, I'm saying that in fact they are not the same. I'm saying they're different. Okay? And what exactly am I saying? There is sufficient evidence to support the claim that the percentage, and we can just use percentage in this case, because same thing, of drivers from college A is less than the percentage from college B. Okay? So I rejected the claim that they were equal to each other because that was what the null was. I rejected the null, that they're equal. And then that means that I can now support the alternative, which is stating that college A has a smaller proportion than the ones from college B. Okay? Now, the next part here is to think about the interval. Okay? The next part is to think about the interval. And So if you noticed that my null hypothesis was written as P1 minus P2 equals 0, and that's my null hypothesis of H naught. Okay? That's actually the difference of the proportions. So, what I want to know when I can create this interval is, what's the estimate for the difference of the proportions? What's the estimate for the difference of the proportions? Okay? And I'm going to use my technology in order to do that as well. Okay? All right. So I go to here, the StatCrunch. I choose my options. I'm going to edit. And now what I'm going to choose is I forgot what size interval I need. So it doesn't actually give me an estimate. Let's use 95% then. So I'm going to construct a confidence interval for the difference. Okay? Construct a confidence interval for the difference. I'm going to compute. Now that gives me an interval for my difference. The difference is going to be between, right, the lower limit of negative 0.248 and the upper limit of negative 0.133. So I'm going to write those down. So the interval, the 95% interval for the difference in proportions was negative 0.248 to negative 0.133. Okay? So that's actually the interval for the difference. Now, what I want to notice here, and I can actually, so let me write this. I am 95% confident that the difference in proportions between college A and college B, proportions of drivers, between college A and college B, is 0. Is the interval negative 0.248 to negative 0.133. So that's my 95% interval, okay? And with that 95% confidence, I now can actually make and draw some conclusions. Here's the conclusion. Because 0, right, which is no difference in the proportions. That's what 0 means, right? Remember, it was no difference in the proportions. Okay. Specifically, that's the P1 minus P2 equals 0. So that, because that no difference is not in the interval, we can reject the null. Basically, it's a lot like that question that I had on the exam where I asked, you know what, is this, what do you think about this claim? Is the claim true or not? And if the claim was in the interval, we said the claim was true, right? And if the claim wasn't in the interval, we said the claim was false, right? Okay, that's exactly what's happening. P1 minus P2 equals 0 is that there's no difference in the proportions. If that's in the interval, then it would be, I can't reject it. I'm going to fail to reject the null. But because it's not, right, we know that the 0 most likely is false. I'm going to reject that claim, okay? So that's what this thing means. This thing here is, it's an estimate for P1 minus P2. It's an estimate for that, okay? We can also do one as an estimate for the difference of means, which would be mu1 minus mu2, okay? And what we're essentially looking for is whether or not 0 is in there or not. If 0 is in there, right, we actually have a difference. If 0 is in there, we have no difference, okay? Our evidence says no difference. If 0 is not in there, we have a difference, all right? Probably going to have to do a little bit of thinking about that, a little bit of study, all right? Okay, so that ends the video on this. basically what we're doing with this hypothesis, like every hypothesis that we've done before, is we're going in here and we're saying, okay, well, what's my null and what's my alternative? In this case, we're comparing two proportions from two populations, college A and college B, right? So my P1 equals P2, and then I have my alternative, right? Then I'm going to put in some of my information. Now, in this case, they gave me a proportion and a sample size, so I had to figure out what an X was in order to figure out, to actually utilize StatCrunch, right? It's fairly simple. It's just a matter of knowing what a proportion is. It's your desired result over your total number of results, right? And just a little bit of algebra. And then we use that to find P. P tells us whether or not we're going to reject or fail to reject. And so we inevitably end up with like kind of an answer, right? And that tells us whether or not we're going to reject the null or not. Don't forget what it is that you're rejecting. Okay? All right. That concludes this video.